Algebra 1, Unit 8B Study Guide, Simplifying Radicals, the second row of problems. So the problem 2 times the square root of 10 times 4 times the square root of 2, I just multiply the things that are alike together. So I notice that I have integers 2 and 4 that are not under the radical, so I can multiply those together, which is 8. And then I've got the square root of 10 times the square root of 2. So that is the square root of 20. Now, before you mark it simplified, we just go ahead and break that down and see if it has any perfect squares. So square root of 4 is 2. We pull that square root out, and then since the 8 is already there, we just multiply it back together. So we can just multiply the 2 times 8, which will give us 16. And then the factor that's left that we could not take the square root of was 5. And so that is the simplified version of 8 times the square root of 20. You can always tell if you're right. You can use your calculator, multiply 8 times the square root of 20 and see what you get, and then multiply 16 times the square root of 5 and you should get exactly the same number. The next one, let's just split up like we did before the fraction, so it's the square root of 9 over the square root of 5. We can take the square root of 9, which is 3, but now we need to rationalize that denominator. So I'm just going to rewrite that fraction, and then I need to multiply the top and the bottom by the square root of 5. So this just changes the look of that fraction, but not the value of it. Square root of 5 times itself is simply 5. On the next problem, we are squaring both of these. So we are squaring the 3, and we are squaring the square root of 7. So do that separately. We have 9 and then 7, and these are multiplied together. So just go ahead and do that multiplication. So that will give you 63. 7 times the square root of 5 minus 4 square roots of 20, you cannot combine those because your square roots are different. But what we can do is simplify the square root of 20. It has a perfect square as one of the factors, square root of 4, which is 2. We'll take that square root of 2, we'll multiply it by the 4 that was already there, so we'll get 8. And then the factor that's left is that 5. Now we look, our radicals are exactly the same, so we can take 7 square roots of 5 and subtract 8 square roots of 5. That gives us negative 1 square root of 5, or you can just write that as negative square root of 5. The square root of 21, 21 is not a perfect square, but we can just check its factors. So 7 and 3 are both prime. You can only multiply them by 1 in itself. So you can't break those down any further. So we just leave that as the square root of 21.